All right, now let's set up monthly change. Okay, and we're going to use continuous compounding, which means we take a natural log of current price divided by the previous price. Okay, and I think 4 decimal places is enough. Okay, and then all right. So now we look at Boston in a little bit. First, we are only considering two cities, Seattle and Las Vegas. So let's go ahead and plot. Uh, okay, I'm going to do something here. So I'm going to copy that and paste it. All right. Okay. And then we're going to make some changes. So select that. So that way it's easier. Select data. So now the x is going to be the same, well, except we're going to start x from row 3, so that should be made to 3, and then this will be, instead of home price, it will be change, Seattle change. Okay, so that will be for Seattle. Okay, now Las Vegas, again, change that to 3, and this will be that one. Okay, so we have these two. Click OK. All right. Okay. So here we have to change this monthly change in home price. All right. And once again, you see that the monthly change it pretty much tracks, except for a couple of instances where the change is more dramatic in Las Vegas than in Seattle. Yeah. All right. So now we want to take a look at the relationship between the two variables. Okay. So we can select the data. Okay. Highlight the data. Okay. And then if you go to data viewer, okay, so now we have the D3 to whatever, and then one variable per column, and we don't have variable names in the first row, so that should be unchecked. Okay, so then click OK, and it gives you the marginal probability for each variable. Okay, and now we click that one, it gives you the correlation type information. Okay, so here it gives you the underlying distribution. It's kind of similar to normal distribution. It's, empirically, you can say that it is probably close to normal distribution, but not sure. And here you see the correlations here. Okay, so between the Las Vegas change and Seattle change, right? And you see there is a tail distribution. You can see there is somewhat of a tail dependency. Okay, so underlying distribution being normal, will suggest that we could probably use Gaussian uh, coupler fit, or the tail dependency. Okay, so here this is a lot of variability here, but relatively small variability as you come closer to this end, and you can see that well here as well. Um, so maybe the Clayton fit will be something that we can consider. All right. Okay. So let's go ahead and we can copy paste this into the file for. Okay. So we can say snipping tool, right? New, and we do that. Okay, so now copy that and paste it there. Okay, so we have the, okay, let's reduce the size. Okay, now let's go ahead and fit the copula. So highlight the data. Okay. Well, before we do the copula, we have to set the probability distributions for simulating the prices, right? So we do so Seattle uh, and this is monthly price change, right? Monthly price change. So all right, let's take Seattle first, and we're going to fit. Okay, so that's the data, and distributions here. Okay, so we're going to leave the lower and the upper bound as unsure. So we cast the net wide and click OK. And we have a fit which is Laplace. All right. So we'll write to Excel. And this fit is based on archaic information criterion like what we have done before. Okay. So we'll put that for Seattle right there. Okay. So we have the fit, and then let's do Las Vegas, and again fit. So that's the data set. All right, let's click OK. And this is also Laplace with a slightly different um, parameter values. Now we'll put that here. Okay. So now we have the probabilities, probability distributions set up. Okay. So now we can make these two as the um, output as well. Okay. And now we can simulate. So go to output and define. So both are selected and the names are automatically assigned, and range name, say monthly price. Okay. All right. So we have, so now at this point we can run the simulation and you will have your simulated value for price change in Seattle and Las Vegas. And of course, that would be um, without or ignoring any relationship between these two columns of values. Okay. Now we want to run copula, so highlight the data and then go to correlation. And now instead of define copula, you say fit copula. Okay. So now you have here are the possible fits that we can try. Okay. Uh, Starting Gaussian T and the Clayton, Frank, and all that. Then you can choose the method of maximum likelihood or Kendall's tau inversion. So we'll leave it with maximum likelihood. Okay, so and click OK. So here we have the copula that's fit. Clayton copula is the one that is selected, and here is the Akaike information criterion value. Okay, and here it gives you how the fit is relative to the actual data. So you have on one side we have Seattle change, and on the other side you have Las Vegas change, and the fit value you see that it closely corresponds with the actual data. Okay. Now we can say write to Excel. All right. Now the location you want, okay, you want to put that somewhere, and let's put it here. Okay. Now it's important that we attach it to the input values, right? So you should select attach copula, okay, and then where to attach it? Okay, there are two, right? So these two are the cells into which the copula should be attached, and then you click OK. Let's close this. So now we have the copula set up, okay, and the copula is attached here. So it is the copula named 1, copula 1, and this is the first variable, and the same copula named copula 1, this is the second variable. Okay. So now we have the model set up, and we can run the simulation. Okay, settings, set automatic. Okay, do sampling, let's say fixed and 1. And let's simulate 10,000. Okay, simulate. Okay, so now we have Seattle prices. Okay, select Las Vegas, then you get Las Vegas price distribution over 10,000 simulations.